morning class. In the previous lecture we have discussed how a input string is processed by the given automaton, and in this lecture we will discuss that for a given input string and a given automaton we have to check that the string is accepted or it is rejected by the input string. As we already have discussed that the basic automaton or simply automaton is having the facility to take a decision about its input string. So in this lecture we will see the same concept, how automaton is checking that or deciding that the input string will be accepted by it or it will be rejected. Before moving to this lecture, it is recommended that you have to revise how the input string will be processed by the given automaton. If the concept is not revised, so please revise it first, then come to this lecture. Okay, for example, we are taking the same example which was taken in the previous lecture. So the automaton is given. In this automaton we have two states, S1 and S2. This state S1 is the initial state as well as the final state. So S1 is the initial state also and the final state also. So input alphabet sigma is given as 0 and 1. It implies that the automaton will take either 0 or 1 as an input. It will not take other characters as an input. It will take only these two characters as an input, either 0 or 1. Fine. For example, the input string given is 0010. This was the input string given. So in the previous lecture we have seen this example. After processing this string character by character, 1 then 0 then 1 then 0. So after processing this string character by character, what is the outcome? S2 as a state. And that is, it implies that when this string is processed by the automaton, after that the automaton will be in the S2 state. Now you have to check that S2 is a final state or not. If S2 is final state, then the input string will be accepted by it, otherwise it is rejected by it. I am repeating the concept. If S2, that is the state after processing the input string, is final state, then we will say that the input string is accepted, otherwise we will say that the input string is rejected. So because S2 in this example, S2 does not belongs to F. What is F? F is set of final states. Because S2 does not belongs to F, so we can say that S2 is not a final state. The same concept is written mathematically as S2 does not belongs to F. Hence the input string is rejected by the automaton. So how you will process this input string? This is discussed in the previous lecture. In this lecture we are discussing what after the processing of the input string. So if you are getting S2 as an input, then you have to check that S2 is a final state or not. If it is a final state, then the input string is accepted, otherwise the input string is rejected. Now let's look at the same concept which is written here mathematically. For example, the string is X, then the string will be accepted by the finite automaton M. It is written as a 5-tuple set where Q is the total number of states, sigma is the input alphabet, Q is the initial state, F is the set of final state, and delta is the transition function. So if X is the input string and Q is the initial state, then applying a transition function of the initial state and the input string, that is this concept, and you are getting a state S which is a final state, then only you will say that X is the accepted, the string is accepted, otherwise we will say that input string is rejected by the automaton. So you have taken or you have understood the concept with the help of example, and you have seen it how it is written at or how it will be written as mathematically. Now let's look at the concept, same concept by different example. In this example also was taken in the previous lecture. The input string given is ABA, and you have to check that the input string is accepted or rejected by the automaton. So in this case you have three states, Q0, Q1 and Q2. The input alphabet is A, B, that is either A or B will be taken as input. Q0 is the initial state, whereas Q1 is the final state because it is marked by the double concentric circles. Fine. So what you have to do, you have to process the input string first. So transition function, which is extended transition function, is applied on the input string. So Q0A, when a transition function is extended or applied on it, you will get Q1 as a state. Then the transition function is further extended. Then if it is applied on Q1B, you will get Q1 as a state. So input string is consumed one by one and reducing to the 0. Finally you will get Q1 as a state. So this is your final state, sorry, this is the state which is achieved by processing the input string ABA. Now you have to check that Q1 is a final state or not. If Q1 is a final state, then we will say that the input string is accepted, otherwise it is rejected. Now check it, because Q1 is a final state and you are getting Q1 here. Q1 is a final state which is written in this way: Q1 belongs to F. What is F? F is set of final states. So if Q1 belongs to F, it implies that Q1 is a final state. If it does not belongs to F, that implies that Q1 is not a final state. So how to write it? Q1 belongs to F. It implies that Q1 is a final state. Therefore, the input string will be accepted by the automaton. In the previous example, the state which you are getting as a result does not belongs. It implies that this is not a final state. That's why rejected. In this case, because Q1 is a final state, that's why accepted by the automaton. So what is the conclusion? The conclusion is the given string will be accepted by the automaton only when, after processing the input string, the state in which the automaton is a final state, otherwise it is rejected. Okay, now let's take one more example. In this example, we are taking the same automaton, but at this time the input string is epsilon. So this is a very special example. No specific string is given, but in place of string epsilon is given. Now what is epsilon? Epsilon is a string of the length 0. What is the meaning of the 0 length string? That is nothing. So there is no input string. So by reading nothing, what is happening here? So if there is any state and the input taken is nothing, that is the epsilon, then the machine will be in the same state. I am repeating the concept. If you are applying a transition function on a particular state and the input taken is epsilon, that is there is no input, then the machine will be in the same state. Okay, now we have to check that this machine will accept epsilon as a string or not. So what we will process it. How to process it? So our initial state is S1 and we will apply the input to it. So input in this case is epsilon. So as we mentioned earlier, whenever we apply a transition function on a state for the epsilon, it will be in the same state. So what you are getting here after processing this string, so you are getting S1 after processing the epsilon. Now you have to check that S1 is a final state or not. Yes, S1 is a final state, hence the input string is accepted. Indirectly, or in other words, we can say that if initial state is the final state, it implies that the machine is accepting the epsilon. Hope this concept is clear to you. If it is not clear to you, please do write to me. I will take some more examples to make it clear. Now this is the assignment questions for you. This is